Today we will see about how to use Iar Workbench for compiling, debugging and uploading the program into MSP430 microcontroller. We hope that you have installed Iar Workbench in your desktop or in a laptop. Please open Iar Workbench. When you open Iar Workbench, the first step, you should create a proper project folder and with a proper format. So the templates are there, lot of templates are available like assembly language or C++ or C language. Choose your language properly here. Let I choose C language because my preferable language, that my program will be in the form of C language. And then it will ask for a project folder. You can create your own project folder in a desktop or somewhere wherever it is possible. Create a folder and give a technical name so that we can remind finally whenever we require the same program. So let I create as HHHH and any file name. You can give any technical file name. Let I take LED. So when you click open, you will get a bare minimum code which is required your program to run. So I hope that you are very clear with what is this watchdog timer and how to control this watchdog timer. So let I copy paste my LED blinking program. Means I want to toggle any of my ports. Either I am using any ports. Let I take port 2 and I am going to make a toggle. So it's a simple code. Hope you all know, you can understand these codes. This we have already seen in our theory classes. So let I directly moving on to the debugging part and other things. Okay. So whenever you completed your task, save the program with .c extension. That is very important because our language, we use C language, our code will be in the form of C language. So .c extension with any technical name is preferable. When you given that, your program is now ready to compile. So go to project. Once again you go to the project menu and there you can able to find an option called make. When you trying to make, it will find some of the errors. If there is any error, it will find out and showcase the error at the bottom of the Iar Workbench. If there is no error, means it will be clearly mentioned that 0 errors like that. When you move on to the next stage is nothing but debugging your code. Can you able to find an option in the left top corner workspace? In that workspace, you just go to the root of your program, root of your project. Right click on the root of your project. There is a first menu called option. Click that option. You will get a pop-up, a small window like this, option for your projects. Go to the category, the first category, general options. In the general option, you should clearly choose your hardware to which you are going to burn your program. So for me, I am going to choose MSP430 F133. So using that browse option, you can go to that particular IC MSP430 F33. After choosing it, go to the debugger. There is an option called debugger in that category. Go to the debugger where can you able to find different debuggers. In the device you choose FET debugger because we are using a FET debugger for debugging our hardware. Means we are using a JTAG cable for debugging purpose. So after choosing the debugger, go to FET debugger. In that FET debugger, there are a lot of options. Either you can connect your JTAG with your USB through USB or through LPT, means parallel port or something like that. Here I am going to use LPT because my debugging will be through LPT. So I am properly choosing Texas Instrument LPT IF. So after choosing the FET debugger, then click OK. Then it come back to the normal mode. Now once again go to the menu project. There you can able to find a option called make. Once again make means you are compiling. When you compile, your file is converted into object file. After compiling, once again go to the project. There is an option called download and debug. When you click download and debug, it will automatically download your program through the port, means the LPT that I have chosen for communication purpose, through which the program will be downloaded into your hardware. Now your hardware will be working whatever the program that we have done actually. Here we are using a port 2. Port 2 logically shifting, means toggling from logic 0 to log 1. Each time it is logically toggling. So accordingly, if I connect any LED in the output, it's look like a toggle. So thanks for watching.